All right. Well, I've been enjoying doing these little C scripting example recording sessions, so I'm going to do another one today. I've got a big one though, so I don't know how I'm going to end up breaking it up. It could be multiple videos. The uh, the plan though is to make a parser, and basically I want to use the C scripting to specify the expression operator logic today. That's the space that I want to look at. So I'm gonna sketch out just a sort of to-do list, a path through getting this done. Since it's kind of a bigger one than the previous examples. There's a little more heavy lifting to do to get started. I'm gonna make a to-do list, and like I said, I might end up doing this over a couple of videos here. Uh, but I'll just be trying to check through all this stuff and uh, get to the point of C scripting and then showing some ways we can organize this to make it. It feels to me like there's a cool way we could end up setting this up that makes it both a nice clean abstraction and the lowest level option for the abstraction simultaneously, if that makes sense. And I want to get there and be able to show some of that, but it might take getting to the second video because I'm gonna have to set up with a parser for a little bit, like the lexer and the just sketching the basics of a parser shaped piece of code before I actually get to C scripting. So here's the plan. We're going to set up a basic lexer. Its structure is basically going to be we have ID nums. These are things made up of the characters A through Z, A through Z, 0 through 9, and underscore. So there will be our ID numbers. We're not going to distinguish between IDs and numbers, at least not right at the outset. We're going to have operators. These are going to be things that look like, I guess we do it sort of like this. Why don't we just say it'll be this or this, 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 this. No. This, this. No, not that, not that, not that. This, 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 or this. So those will be operator characters. So any combination of those in any length is an operator in this system. I left out open parenthesis and close parenthesis. So each of these is just going to be one separate, like unique token type. And then there's white space. And also I'll probably have errors sooner or later in the lecture. I'm not sure where. Maybe I've covered every possible character in such a way that I won't have any errors, actually. Oh, well, I left out the string literals on purpose. So if I ever wanted to come back and add string literal stuff, I have some space in the syntax left, and those can be errors for now. So, yeah, there's a little bit of room left in the syntax if I do it this way. I could also revoke like semicolon, for instance, to make room. That felt a little funky to include, maybe. So we'll do it that way. White space, errors, everything else. Okay. So then once we have the lexer set up, then we'll do a first little mini parser. We'll just use a few operators, like a couple precedence levels and one that goes right to left, like equals, like an assignment operator kind of thing. So we'll do these three operators. We'll do a parser for an expression parser for these guys. on it. And then we'll do a cleanup. We'll do that like the recursive descent way first. How do you spell descent actually? Is it C or S? Oh, it's both. Wild. Okay. Okay. Crazy. Expression parser. So we'll do a recursive descent version, and then we'll do a precedence table version. And then we'll do the C scripted precedence table version. Then we'll do C scripted interpretations. And then we'll extend it with some extra features. This is where it becomes kind of like probably a second or third video. So I'm going to actually build up some features into this just so that it's not just an example, but kind of like a cool starting point. If you ever want to slop together a parser out of C scripts, you can start with this and it'll have prefix parser or like prefix, postfix, bracket operator, stuff like that ready to go. So prefix, postfix, operators, bracket operators, and then I guess like all of these are like C scripted at this point. So like what would this be like? C script like structure builder, the last one I want to show. Okay, so I think this is a cool one. I haven't done this with C scripting before. Some of the stuff I've shown is stuff that I've actually explored before and like iterated on. This time I'm going to iterate on a C scripting use case that I haven't touched yet with C scripting. But it's also just one where we got to do a little bit of heavy lifting to get the prerequisites up and running since we're working from scratch. So I guess I'm going to just get into it. Let's see here. So I guess that's about it. I maybe also need to take a minute, maybe to really what today I'll do. You know what? Yeah, I'm changing my mind. So everything I described is still the to-do list, but I'm gonna save it because I might be doing a different video right now. This is not the beginning of the expression parser. Here, we're gonna just drop in right here is a to-do list. There's the major to-do list. I have to restore the indentation because Coder virtual whitespace has a design flaw with regards to spaces, and so it just clobbered my indentations. Okay, so there's the there's the to-do list. Let's get back to just the other thing. The example I was looking at was the state machine one. Where is that? Stack machine. I'm thinking like I have a duplicated base layer. There's got to be another place where I have this already. Right? Like here it is again. I think I need to make a base layer for the examples. So just so I'm remembering correctly, this comes with symbol set base. See, I'm gonna just put like examples.base.h, and then I'm gonna do examples.base.c, and I'm gonna just organize some stuff a little bit here into those. So this becomes more like that. I think I'd like to build this up. But we're gonna just work on this code base a little bit. So this C scripting repository is kind of becoming a little bit of a code base with a weird structure, since it's also a library. It's a code base inside of a library. The library has a base layer within itself, and then the example folder has a base layer within itself, right? That's how this is working out. So then build all examples is going to be like something like that. Build all examples .sh. Yeah, I think this will just be easy. I'll just take this and take all the ifs out, right? Like this is build all examples, right? Man, maybe that's a good reason. I just had a light bulb moment. Maybe it's a good time to return to the notion of building from C code instead of from bash scripts, because now I can equip C with symbol sets. So maybe it would be better because I could do stuff like this where I make lists of examples, and then sometimes I want to run one of them and sometimes I want to run all of them so much more easily. I think that would actually I might need to put that on the to-do list too. There's so much I have to redo about my style with symbol sets. It's kind of crazy. So anyway, in the meantime, Okay. So we have a build all examples, and I'm going to add in the expression parser. Let's try to get back to the expression parser, but base layer first. Okay. Doesn't matter, so I'm gonna just cut that out for now. Okay. Back to the base layer. So this has got it. Hooks. You had a base layer too, right? And yours had a little more because this has the arena thing. So the base layer needs these. These were already copied. And then let's see. I guess it would be in hooks H, right? There'd be here they are. So these are the new pieces. I don't have any of it. I don't have any of it. Oh. If I go back here, isn't all of it right here? There we go. Little baselet. Little base layer. So I'm gonna actually rename this. This is gonna be typical base layer stuff. And then this down here is going to be symbol set specific base layer integrations. That sounds good. Yes. I kind of regret that name now, actually. It's longer than I was hoping it was going to turn out. Symbol set specific base layer upgrades. It's not that much shorter. Could drop the word layer. That helps. Symbol set specific. Why don't I just call it symbol set specific upgrades? We're in the base header. Typical base stuff and symbol set specific upgrades. I like that. Okay, this one I did it right. And was there another one that was like example one? Example one is super lame, and I don't think I've done any of this stuff to make it a little better, but here we go. Examples.base.h C example1.h. So this goes here, symbol set examples.base base.c. Okay, so why don't we do, if you're gonna need these, just stick them in here. And there we go. I never love it when I do things this way. I always end up wishing I hadn't bothered. Okay. You just have to use it right. That's the way I always do it. I don't know why, but I just have a gut instinct that I prefer to keep all of my includes in as much as possible one big spot. Feels like that's the pattern. That, you know, if I keep everything working in such a way that that pattern keeps working, then everything works. But if I ever make an exception, then some things don't work that way anymore, and then it all gets complicated. So, yeah, just stick with the pattern, even though it feels weird sometimes. I don't know. So where is this one happening? Okay, so maybe the mistake is that I want them in the header. Sometimes I put those things in the header. Oh well, moving on. I'm doing it like this. I'm not quite sure. Okay, everything is building again, except that parser. Right. Build all examples. Parser. Okay. So what's happening here? I don't have a main still. I guess that's the point. It's not really giving me a error message I'm used to seeing a lot, but I did forget to give it a main. No. Yeah. Does that work? Okay, and then we can put in the base layer for the examples. And there we go. So new example up and running with the base layer. Little bit more of a repeatable pattern than it was before, so that's good. Now, what about this part? I guess we start with the Lexer. Where's my to-do list? Yeah, I just get, oh, it's right here. I was sort of like overlooking all of this, thinking like it was on the scratch, and then, okay. So the Lexer looks like this. We're gonna have this type called a token. It's gonna have a kind field. I'm gonna just put a little exp namespace on this project for expression. So expression, token kind. We have them right here. So we'll do error as the 0, 1. ID nums for ID num operator, open paren, close paren, open bracket, close bracket, open brace, close brace, white space. I'm moving that up to position number 1. And error. Okay. And then I'll put a count at the end. I won't all caps that because it's not at the same level of outside the system as count. It's inside the system. Errors are just information. So there's the token kind. Now, different ways you could do this. I'm going to do it. I guess I'll do it like this. So we're going to use a single 32-bit position for each token. That does actually necessitate one more type of token that I forgot about, the end of file token. That'll go there. Okay, and then so the idea of a lexer then is just an implementation for this, right? You need an array of how do we want to return? I guess we'll take an array of tokens like this, and then we'll do that, right? And so then well, depends on if you want to do your lexer and parser in one pass or not. But let's bootstrap here. We'll do day 1 stuff. We'll do it the easy way, right? So we'll do exp lex. This seems like an easy way to get it up and running. So then you do, there's your text. Pops an array of tokens covering the text. So let's get this much going. Here's our lexer types. Here's our lexer functions. We'll do lexer functions here. Entry point here. Now, one very easy way to set this up is I can overpredict the number of tokens by saying we're going to push an array of tokens, not the type array type, the memory block for tokens. 1 for every possible character, because at most, and 1 extra, because at most that's how big it could ever be, and I can calculate that off of this. Sometimes it'll over allocate by a lot, but we're going to put most of it back, and the amount you take off of an arena usually doesn't matter if you're putting a lot of it back right away, because it's just an increment and then a decrement, right? As long as you're not taking so much that you force it to allocate more. So in this case, these arenas don't grow anyways. So we are limiting the size of the input text that you can pass, And the next upgrade after this would be to use like a stretchy buffer on your tokens, or you could do like, I mean, you could do a chain, right? You can always just accumulate them on a chain, and then when you need more, put them on the next step of the chain. Maybe we just do that today. You know, I want to make this kind of useful, like at a useful level of quality. So we could just skip to that. Skip to that structure here. No. This is just our bootstrap. This is just our bootstrap. So we're gonna go like this. We go set up like a footer and OPL. No, this isn't the sort of thing where we put the plus there. That'll make it more confusing in a minute. We'll just do this. So we're at the beginning, and what we have to do at each step is you switch on the pointer, and you look at, okay, which of these cases are we in? So let's see, end of file is a unique case. We can't be in that case. Error is going to basically be the default case, right? So here we'll do error. Okay, so white space will get, you know, all of this stuff. Tabs, V's and F's. Okay. So there's white space. Now, I don't really want to do default here because ID num is an even bigger catch-all. So this is going to be explicit. In fact, the errors come from the following: semicolon. But then there's also everything. But they're both going to have to live inside default together. It's just too bad. Okay. So error or ID num. These are both ones that we want to calculate a little more carefully. But these ones, so this is a list we can make. We have it actually in the to-do list already. This string here. So for each one of you, I want to create case. You are a special case. Operators. Open paren. Close, open bracket, close, open brace, close. Right, okay. White space error. Operators. All the different delimiters. And yeah, that's it. Yeah, that's it. So those spit out tokens. And so like with these ones, what you do is you go, okay, at each step, the token we are creating is at, oh, maybe I should be using a U32I. Make this, I don't know if that's going to matter. Never quite sure. No, I'll do it this way. Okay. Position. Okay. Tokens. So each token gets its position wherever it starts. And then I have to make sure I'm doing this right. It's not minus opal, it's minus the start. Alright. Then we look at the character. If it's one of these, for instance, we do TP kind equals exp token kind open parent, for instance, right? Each of these is setting So the other thing is, in this case, I have to tell it how far to advance the pointer. So I advance it by 1 in all of these cases. And then at the end, it advances this. So we get 1 at the beginning, well, position at the beginning. We get the kind from the switch, and then we figure out how far we advance, and we then advance the token so that the next token we generate marks both the end of the previous token and the beginning of the next one. And then these ones get a little more fun. This one's interesting. So here you go for as long as putter. You do 1 first because you know, because you already know. Then, after that, you keep checking. Is this white space? So, it looks like this. But you also have to check footer is less than text.size because we don't have necessarily a null terminator when we have a size-based string. Yeah, that should do it. Now, a similar sort of thing is happening here, but this is so many characters that it feels like it's going to be a little bit ridiculous to spell it all out, right? Like, surely I can't just do a giant and on all of these. Not gonna make me happy. I'm not gonna like, oh, underscore shouldn't even be in this list. You didn't belong here. That should have been a minus sign. That's what's missing. Okay, so yeah, I guess we just do that. I don't know what else I would do. Oops. Better be careful there. Okay. Okay, except this is all wrong. These shouldn't all be ands. These should all be ors. Grouped together under the one and with the size. Oh dear. Okay. So, another option is we can make, this is so crazy. Okay. Okay. Token kind table. So if you are any of these, then you get white space. If you've got any of these, you've got an operator. So that'll be like each case becomes a token kind table. colon that's somewhere in there inside of that. I'm going to have you rename yourself to a semicolon for now. Now all the real colons who are not inside a quote, I'm going to have you rename yourself to square bracket equals space. Good. Progress. We'll take 2 at a time. Okay, so there's token kind operator. Now, just clear out this stuff. Let's organize these. These are still going to need to be a little different anyway, because unlike everything else, these aren't going to group together into singular gloms of tokens based on being the same type. They're going to all stand distinct. But what we could do is we could do like a for loop to build out things like the ID num stuff. Token kind table I equals token kind ID num a z right, so there you go. You put your ID numbers together that way. I guess if this clears to 0, then everything I don't set is automatically by default an error, which clears up this. So I think that's the way to do it. Because then what you do just thinking how far do I want to push it. It's feeling like you do it like this. So you take all that and you say, okay, we put that in there. I'm gonna put these in there too. So this much can go away on each of them. All of that just boils down to square bracket equals case space becomes token kind table square bracket open, right? And then what I'm going to do is I'm going to come in here and I'm going to set a high bid on each of these, which I'm not doing on any of the other ones. And so then the tokenizer becomes the following. You go, let's just go kind token kind table. So we do character lookup. Okay, we still have to do another careful thing, which is if you give me anything that's not basic ASCII, then I'm going to assume it's UTF-8 and that it should be an ID num. That's just the easy way out, right? That way, if you want, the other easy way out is to say that it's an error or something, or that it's all white space. But this is the way out that preserves, I think, the most possible uses. So anyway, if this is less than 127, then we can get a kind off that table, right? What we do is we say how would you spell that out? Here it's 1. I think I would just do this. I think that's what I would like still. All right, make a match. So that gives you the kind, and then what you do is you go if kind and 1 bit shift 31. Then what you're going to do is just increment the pointer by 1. Otherwise, so the ones that have a high bit set, what they're saying is I take 1 token at a time, even if I am sitting next to another copy of somebody from the same token kind class. Each of our characters is a single token. And token kinds that are in this table that do not have that flag say, okay, after you see me, the rest of the token, like the rest of the characters that you see after me, they're of the same token kind. We all get grouped together into 1 token, right? So then what we do is we go, okay, so for as long as, first of all, we've looked at 1 pointer. We've looked at 1 pointer, so we're good on that one. And as long as we still could look at more, and the token kind that we find there is equal to the kind we've already got, then go farther, right? So there you go. That's a lot better than doing the whole switch based thing. So that figures out how far your pointer goes ahead. Then you increment your token. Now, if your pointer goes all the way to the end, right? If your pointer goes all the way to the end, then I output 1 more token. The kind is end of file. So what happens here then is you get in a string, and across that whole string, you are going to assign sort of a blanket. The sequence of tokens blankets the whole string so that each character is a part of 1 token in the token array that you output, right? And so the tokens then are actually stored as this array where they store where they begin, and the next token stores where the previous token ends, so that we store 1 position and 1 kind for each token. And then at the end, there's 1 last token, the end of file token. What that really means is it's telling us, giving us a sort of homogeneous way to access all of the tokens besides that last one, right? The end of file token is different because it doesn't have a next one to give it a length. So the end of file has no length, which makes sense. But all the other token kinds have a length, So for all the token kinds besides the one that's at the end of the array, the end of file token, all the other tokens have a range of characters that they cover, because we just look at what where the next token starts, right? That's the idea. So then I need to package up the tokens and the final count of tokens. So the final count of tokens, right? Okay, so let me put in some. Here's a static map of characters to token kinds. Here is the computing of text. Like this takes in the string and outputs the tokens. Here we put back some memory. Why don't we do it like this? Allocate fill tokens array. We'll do it like this: token cap, right? And then down here, put back extra memory. So the way you do that is arena pop amount, which I do not have in the base layer yet, but which we can get. And then you use your arena, and you say pop amount. The amount in this case is the size of one token times the amount we said we took minus the amount we actually took. All right, here's how much memory we set aside. Here's how many tokens we actually ended up with. We calculate that as TP minus the base of the array. And so that puts back all the memory we over allocated after doing the tokenizing. And so there you go. Arrange as result. Okay, so how are we doing there? How does that look? Oh, right, I stored these as a byte, and then I went and used this, like it's got 32 bits. So let's see here. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Something like that. So it's not even 16. 16, less than 16 means 4 bits, right? It should work in 4 bits. So I can totally just say, no, I misspoke. I really meant, I do want to stick with the idea of using a byte. I just meant to put the high bit. I said high bit, but I wrote 31 because I was thinking 32-bit. Okay, so. Good. So everything builds now. And we... And we would like to see the array of tokens now, please. So let's grab Lex. I'll stick this here. And I'll stick this here. And now I just need to spend a little bit of time figuring out how to get, maybe, okay, do I have anything else in the base layer for setting up a string? Okay, so I should be able to use that on an array, I think. I could do it like this. Text one. Right, this should work as a way to express some text, put new lines in it, make it like a text file. Well, no, I'm overcomplicating this because this is just an expression parser, not a text file parser necessarily, right? So what I mean by that is I'm more concerned about testing stuff like smaller. Like, can we get parenthesis, foobar space, plus 100 times 3 up, close parenthesis, brace, bracket, brace, parenthesis, colon, something like this. I think more or less, this more or less does the tricks that I need. Probably. Okay, so if I have you parse something crazy like that, and you give me back token array. Okay, I'm gonna pause for a sec. Okay, I was getting close here. Maybe this will just be video 1, getting the Lexer up and running. It'll be a little while to build out an example like this. Tokens. So then what you can do, is just, if you want to read out your tokens, what you can do is do something like, this is the Mr. Fourth code base, printf. Something like that. Okay, good. So okay, what I need here is the name of the token kind. Unfortunately, I have to do it like this. So token, I need to get the name kind of the token. New line. No, we'll just do it right here. Put in some quotes like that and new line. Okay, that should do it. So now it's going to be token kind string, and we need the size of the token. So token length, if you prefer, token size, and the token pointer itself. The token pointer itself is just we should put the text out here. So text. Right, so it's just the text plus the token position. And so then you've got like the token is just tokens I, right? So that's that. That goes there. Then the only annoying part is, since this is just an enum, I have to get its name from an X list real quick. So this is going to become count goes away, exp token kind underscore X parenthesis. That's not necessary. Comma becomes parenthesis close slash. Define X n exp token kind n undef X exp token kind X list. Okay, so that means I should be able to do this, define X and exp token kind case and token kind string equals the name break undef X exp token kind X list X, right? Seems right. Ah, you need me to comma those things apart. Right, token kind count's not a real enum value, actually, guys. That's a static constant relative to the enum. It's different. I'm gonna just turn the warning off. Where do I go for that? I guess this is all happening from build all examples at this point. In the options, I just say no more switch error warnings, please. What? Wait, what? I said build all examples, no switch, options. Build all examples. Warning, enumeration value, token kind, right? No, I mean, I get that. But I put no switch. Expression parser, options, no switch. What am I missing? It's not like this has to go first, is it? No. Right. Expression parser. This is build all examples. Where's the it's like, I mean, that's how you do it, right? Am I missing something? Let's just echo this line instead of running it. I don't see the options at all. Options. Oh, right. It's one of these things. You can't have spaces unless you put quotes. It's one of those things, right? Right. There we go. Okay. Okay, now we also have to calculate the token size. So like I was saying, I want this to work. Let's go and I think this through a little bit more carefully. So the token count should really be the number of tokens so that there's one extra allocated, right? Rather than the count that's in the array reflecting that there's an extra allocated slot. I want it to be that there's one extra, the terminator, the end of file token is allocated past the end. Just like when I have a string, if I say that the string, has a length of 10, and I am building a struct that's like, here's a pointer and here's a count, I put those together, I can still put a null terminator in the 11th slot when I'm allocate it, right? Same idea here. That's what I want to do. What that means is, we look at this, I've already actually done the allocations that way, but that's wrong. What I need to do is first allocate all the full token array completely, right? Because I forgot to put a TP plus right there, so that way that the cap does not get erased from the arena, right? I don't want it to get erased from the arena. So first fix this bug and have it actually keep the terminator token on the arena along with everything else, but then drop it when we go to repeat to tell how many tokens there are. So there's always at least one, because this happens right here, so it's outside the loop, right? And so here we can see the logic of this, right? This over allocation being text.size plus 1. If each character in the loop across this generates a separate token, and then there's an end of file token, that's the cap, right? And so the plus 1 in either case is sort of the same thing. It's the extra slot for this. And then we just hide that in the count. That way we can do a loop like this over all of the tokens. And then when we want to calculate the token size, the way we do it is we go to the tokens that we're currently on, and we also go to the next one. And we can always assume we can go to the next one so long as we're iterating inside the range given by this, right? So this is like a property of the structure that is guaranteed that for the valid range, not only each slot, but each slot's next, like the successor, the plus 1 of that slot is also checkable. That way you can take a length like this, and now you've got a token size, and you can use that to limit the length of how long this will be printed out as. And then you, just use, I guess we already have the token here, so we can do it like this. Token position, this can be token plus 1 position, and then this is the token position again for that, right? So the token kind, the token, yeah, this looks good. Okay, so now let's set up to run the parser example. Right? Reload the project, F2. Okay, so let's check this out. Here's what I put in. Open parenthesis, good. Foobar, good. Space, good. Plus, good. Space, good. 100, good. Space, good. Star, good. White space, good. 3, good. White space, good. Up arrow. Okay, here we've got something interesting. A new line, which has been printed correctly by my text editor so that it looks like nothing. A pair of tabs. Yeah, there they are. I have my tab stop set to 2. That's correct. And then a space. Good. 17. Good. Close parenthesis. Good. Open parenthesis or open braces. They didn't congeal. That's good. Open brackets didn't congeal. That's good. That's all working the way it should. Operators congealed. Now, here we go. Error. Did I say colons were errors? Maybe I did. I thought I said that colons were going to be in the operator class. And that semicolons would be errors, and that. So I'm going to go double check that. That should all congeal into one big operator. Although I should also have an error in my test case. So let's take one of these in there, for instance. Okay, so what's going on with the deal where that's not making it in? Oh, look at this. This one's messed up. Yeah, that's right. I did the funky rename thing so that the whole rearrange would be safe, and then I forgot to undo it. That was supposed to be the last step. Okay. No, I just ran it from here. Oops, sorry, I'm bumping my mic. Okay, yeah. So this is now it. Let's wrap here for this one. Maybe I need a little break, fill up my water, and I want to get on next to the second step here. The expression parser for plus star equals in a recursive descent form. That's the next step. So next video doing that subject.